Hi dear students. So in previous lecture we have studied FDM, means frequency division multiplexing. So now we are going to study the TDM, that is time division multiplexing. So based on diagram again you can understand. In FDM what happen is, whatever bandwidth of channel is there, that we divide into different users. In TDM what we do is, for each user we provide the complete bandwidth of channel but for a specific time. Clear? For a specific time. Means in TDM, instead of dividing a frequency of channel, we provide the frequency for each user but for a mentioned time. So you can see here in this diagram there are three systems that are using the common channel. This is the signal of first system, second system, third system and fourth system. So these four signals are combined using the multiplexer. Okay, then this is what? This is a common channel. Okay, so this common channel is provided for what? System 4 first. Okay, so here complete channel is provided but for specific time. That may be for 1 hour. That may be for 1 hour. Okay, then when that system 4 gets the specific time, for example 10 to 11, it can transmit its data only within 10 to 11. After 11, it should relieve the what? Channel. It should not, it means it can't transmit its data. It will relieve the channel. Then maybe 11 to 12, that channel is provided for system 3 to transmit its data. Clear? Like that 11 to 12 it will transmit its data, and at 12 it will relieve the channel. Okay, then 12 to 1 system 2, like that 1 to 2 system 1, again the same procedure. 1 hour for system 4, 1 hour for system 3, 1 hour for system 2, 1 hour for system 1. Like that again the same until they finish their transmission. Understood? Any doubt here? So in TDM what we do? In TDM we provide the complete channel bandwidth for each user to send its signal but for a fixed time slot. That is why we call it as TDM. Means here frequency is not divided, instead time is divided. That is why time division multiplexing. So it divides the time among users. Clear? Okay, then TDM allocates fixed time slot for each user to send signals through a common channel, and each user must transmit its data within the given time slot to it. So definition of TDM is what then? TDM is a transmission technique that allows multiple users to send signals over a common channel by allocating fixed time slot for each user. By allocating what? Fixed time slot for each user. Understood? Okay, now consider example. For FDM, the example is FM channel, right? Because frequency is divided. As I have already told you, 92.7, 98.3, 98.7 different channels are there. So for those channels, the frequency range is given. Within that frequency range only they can transmit their data. Like in TDM, example is TV channel and advertisement. So whenever you watch any TV channel, you get some advertisement in between. Okay. Then whenever that program is going on, whenever the TV program is broadcasted, at that time that program is using the complete bandwidth of channel. Understood? But for a particular time. So whenever you watch serial, first 10 minutes is for that serial, then next 3 minutes or 4 minutes for one advertisement, right? So 4 minutes for advertisement means what? That time slot is given for telecasting that advertisement. Understood? Then after that 4 minutes, again serial gets start, this program gets start for another 5 minutes or 7 minutes or 10 minutes. It means that time slot is again allocated for the program. Understood? So this is how using a common channel they telecast their programs but in different time slots, and it is the best example for TDM, that is TV channels and advertisement. So they use entire bandwidth for short time, correct or no? TV channels and advertisements use the entire bandwidth of the channel but for a specific time. Means first program gets telecast and then advertisement and again program and again advertisement and so on. Understood? Okay, then TDM uses which type of signals then? TDM uses analog signal and digital signal, both. Clear? Most of the time, the time division multiplexing uses time division multiplexing uses digital signals most of the time. Okay. Then let us see TDM with another diagram. So this diagram also represents TDM. Okay. So what we can see in this diagram is, here there are 4 users. Here there are 4 users, user 1, user 2, user 3 and user 4. To make them differentiate, they have used different colors here. Okay. And they are using the same channel. Okay. But at different. So at first time the blue color signal is transmitted, then in second time pink, then yellow, then green. Like that they are multiplexed, means they are combined and they are allocated with some time. Understood? Like that again the next transmission slot. Clear? So for example 10 to 11 what? Blue, 11 to 12 pink, 12 to 1 yellow, 1 to 2 green. Again when green transmission ends, it starts with first user. So 2 to 3 blue. Clear? 3 to 4 pink, 4 to 5 yellow, 5 to 6 green. Okay. So to better understand TDM, you remember the example. By example you can remember the whole concept. TV channel and advertisement. Clear? Okay, now one more point to make you more clear, I will show you how TDM and FDM are analyzed. So we represent the frequency and time with 2 axes, x-axis and y-axis. So this is x-axis and this is y-axis. Okay. So x-axis always represents time. X-axis always represents time and y-axis always represents frequency. It always represents what? Frequency. So in FDM, how we represent users is, so from 0 to 10 frequency, user 1. Clear? 10 to 20 frequency, user 2. 20 to 30 frequency, user 3. So this is what? FDM. Understood? Any doubt here? Okay. Then come to TDM. FDM is clear, no? So why I have drawn diagram like this? Means here time is not divided. The bandwidth of channel is divided. If user 1 wants to transmit data, then it can transmit data from in between frequency range 0 to 10. If user 2 want to transmit, then it can transmit in between 10 to 20. And user 3 can transmit data in between 20 to 30. Clear? Okay, then come to TDM. So in TDM, again we use the same axis, x-axis and y-axis. X-axis represents same time, y-axis represents frequency. Okay, so in TDM already you know, that is we divide the what time. So here 0 to 30 frequency is there, 10, maybe 20. Okay, so for user 1, complete frequency of channel is given here. 30 Hz all frequencies given for user 1, but for specific time slot, means that may be for 0 to 1. 0 to 1 means that may represent 1 hour. Clear? Okay. Then for user 2, again complete frequency means 0 to 30. Complete frequency is given for user 2, but for a specific time. So that may be 1 to 3. 1 to 3 means what? For 2 hours. User 2. Then like that, user 3 is also provided with the complete frequency from 0 to 30 Hz, but for a specific time. That may be from 3 to 8. 3 to 8 means 5 hours are given for user 3. Clear? So what it means is, in TDM, user 1 can transmit its data for 1 hour, first hour. User 2 can transmit for its data in another 2 hours. User 3 can transmit its data after user 1 and user 2 in next 5 hours. After 5th hour, user 3 must relieve the what? Channel. Clear? And user 1 will start its transmission after user 3. Again, the continuation of the same process. So this is what? TDM. Hope you understood TDM, FDM clearly. Thank you.